Hello everyone, I'm Rekha Murthy, Assistant Professor from Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology. Today I'm here to explain about the one of the cycle 1 experiment, that is from the Electrical Machine Laboratory 1. So the experiment which we have left out in the cycle 1 is a polarity test and connection of a three single phase transformers in star to delta, delta to delta, and VV, that is open delta, and determination of the efficiency and as well as the regulation under the balanced resistive load. So before we go with that, why do we conduct this experiment? Why this polarity test is required? So it is very much required to know the relative polarity at any instant of the primary and secondary terminals for making the correct connections when two transformers has been connected in parallel to share the load on a system. So that is why we are going to conduct this polarity test. Where here in the polarity test we'll be having the two concepts. One is the additive polarity and the subtractive polarity. In the additive polarity, we will find that the two primary end, we are going to short it. The P1 of one transformer should be connected to the S1 of the another transformer. It will be shorted. The other two end, which is left out, that is P2 and S2, there we are going to connect the voltmeter. So after giving the required supply, that is a single phase means 230 volt, then definitely we have to observe that in the voltmeter we should get the it should read 0, because the whatever the EMF is induced on both the primary and the secondary, it will be it will be in the such a way direction, it will be in the opposite direction. If it is like both the EMFs which is induced in the primary and the secondary, if both are getting summed up, okay, then the voltmeter is going to indicate a double of the voltage, that is around 430 voltage, like that. That time it indicates that we have to interchange the S1 and S2 terminals. Okay, but we have to make ensure that during this polarity test, one more observation you can observe. Sometimes what will happen, the voltmeter is going to read the 0 value. So what is that effect? So that is actually whatever the EMF is induced in the primary and the secondary is quite opposing. So that is why it will read the 0 reading. So that is what we are very curiosity to know, that what will be the how do we conduct this polarity test, so that you will come to know which is the dot convention which represents the where exactly the current is entering into it. So which terminal will be the first terminal, whether it is where the P1 is existing and where the on the secondary side where the S1 is existing. So where we have to put a dot convention. So let us, so that will be the polarity test significance, why we have to conduct this. And the next part of it, we are making use of a three single phase transformer. Okay, so it will be available with a single phase transformer. So far in the first three experiments we have conducted only related with the single phase transformer. Now what we are going to do, we are taking up those single phase transformer, three single phase transformer, we are going to use it to make a three phase supply to constitute one single to constitute a three phase supply. So we are constituting a three phase transformer. So here what these are the possibility, let us see what are the possibilities are there to connect the three independent single phase transformer to work as a single three phase transformer. See, three single phase transformer can be connected in any configuration, as you all know that. So three phase transformers such as like in the star to delta, delta to star, star to star, delta to delta, right, depending upon to the load requirements. So like that, there are different possibility connections are there for the three single phase transformer in a bank. So what is advantage? Why do we are using this? Because three single phase transformers which is connected in the different fashions, okay, as such what we had discussed now, the that we need to consider the dot convention. right? So depending upon like required current and the voltage levels, the relationships, so that is why we are going to make use of a three single phase transformer which is connected in the different fashions, that is star to star, star to delta, all that. So these are the different configurations which we are following, that is star to delta, delta to delta, and open delta connection, right? So let us see that here. To conduct this experiment, we are going to require the apparatus. As such, we require the single phase transformer. How many? Obviously three. Okay. And also we since the heading indicates determination of efficiency and regulation under a balanced resistive load. Definitely, we require one resistive load bank. How many? That is nothing but the three-phase resistive bank load. We require a three-phase resistive bank load. Okay, that one we require. Then also we require the watt meters. So we require the UPF wattmeters. So because since resistive load bank we are using, so we require the UPF wattmeters. So we require the two UPF wattmeter on the primary side and onto the secondary side also, because we are connecting the different fashions. So one side will be star means the other side will be delta, or some or the other fashion. And in addition to that, we require an ammeter and voltmeter. The ammeter definitely it will be in the range of a 0 to 10 amperes. Since here we are using a 2 kVA transformer, so it will be the what is the rated current will be around 8.75 amperes. So that is why we require the 10 ampere of ammeter. Then voltmeter, definitely since we are using three phase supply, no, so we have to use the 600 volts voltmeter, and another we can make use of a 500 volts. So these are the apparatus we require it. Now let us see that the connection part of it. So here, as I told you, as per the theory, the P1 and S1 will be connected together, or it will be connected in to the voltmeter. The other side of this P1 and S2 is connected. So with this combination, we have to apply the supply voltage of a 230 volts and observe this voltage. So if in case this voltmeter is going to read, if it is indicating 0, then it indicates that it is your the what is that, subtractive polarity. Okay, if it is reads 0 means it is a subtractive polarity, or if it is reading the double of the voltage, that is 400, above the 400 volts, means it is indicating the additive polarity. Okay, now if it is reading additive polarity, means what you need to do the procedure. We don't want it should read double of the voltage, right? So what we have to do is we need to interchange the secondaries of S1 and S2, right? So when you interchange means this is what the circuit connection will get changed into in this way, in this fashion. So again you will observe the voltmeter. Definitely it will read the subtractive polarity, so it will read a 0 value. Okay, so after confirming that which is S1, which is S2 properly, so that you can understand that where actually the current is entering into the loop. So then we can decide this is about the this will be the P1, this will be the P2, and definitely here it will be ulta. Okay, so this is what while doing the connection, so this will be the S2 and this will be the S1. Okay, so this is how we have to confirm it, and the similarly we need to carry out for the other two single phase transformer which is available on the board. After confirming this, you can also take down the readings for the both of the types of this what I told, additive polarity voltage how much you're getting, and subtractive polarity how much the voltage is getting, so that we have to tabulate it. Then coming to the next, this completes your the polarity test. After completing the polarity test, we have to make use of this single phase transformer for the further connections. So like that we require the three single phase transformers, that is T1, T2, T3. Okay, so now you can come to know if this is a P1, so this will be the dot convention what we have taken. So this will be the S1, and here also you can mark the dot convention. And now for this transformer, we have to give, first you need to draw these transformer T1, T2, T3. Don't start with the initial step. Always first you understand how to draw the circuit diagram. First T1, T2, T3 has been written. Now P1 should be connected to the L, then that is wattmeter, then the M is connected to the ammeter. Then you can see that it should be connected to the one of the three phase supply, that is R phase. Similarly, on the other side also you can observe. So this is the connection with the star to delta. Okay, so what you can observe, the primary will be star and secondary will be delta. So in star connection, what is the rule? The one end of the each of this one end of the winding should be connected to the supply side, and the other remaining, the finishing end, that should be connected all together. Okay, so here you can see the same observation. P1 is let out to the R phase, P1 of second transformer is also let out to the Y phase, and P1 of third transformer is also let out to the B phase. Okay, now the remaining is P2 of first transformer, second transformer, and third transformer. All these P2 should be shorted together. Now what is left out here, onto the P1 also we have to connect to the another wattmeter. It is almost just like a 2 wattmeter method. So here the P1 should be connected to the L of the second wattmeter, and M and C is shorted, and M is connected to the B phase, and VV is shorted, and that shorted end should be connected to the second transformer of the P1 terminal. This completes your the primary of the circuit. Secondary part of the circuit is it should be in the delta fashion. Delta means S1 should be connected to the one end of the supply. Even the S2 is also been connected to the other end. So it is, we have to make ensure that the starting end should be connected to the load side. The finishing end, that is S2, should be connected to the starting end of the second transformer, that is S1. So S2 and S1 should be shorted. Similarly, for the next configuration, S2 and S1 should be shorted, and the last terminal which is left out, S1 and the S1 and the S2 should be closed, and it should be connected together. That is, S2 of the third transformer should be connected back to the beginning of the loop of the S1 of the first transformer. This is what the delta fashion. So delta fashion means you will find that obviously that is on the delta side, you will find on the delta side, you will find that here if you find this is the S1, okay, of the first transformer, this will be having a S2, and S2 the another this will be the S1. This is how it is shorted, and S2 is coming here. Similarly, the next phase S1 is coming here, and the S2 is coming here. So this is how we need to make sure that we have to complete this loop. So this will be in the star fashion, doesn't matter. So P1 is let out, P1 will be let out as usual, and P2 will be P2 will be so this will be the P2. So here you can write this will be the P2 which is left out, and this will be the another P1. P1 of first, P1 of second transformer, P1 of next transformer is let out, and all the second terminals will be shorted here. Okay, that is what the star connection. Then on the secondary side, what are the equipments do we require? Again, we have to just whatever you have written on the primary side, we have to follow in the similar way. Okay, so first we have taken the this was your wattmeter. Now you can take up the ammeter. So secondary is connected to the ammeter. The other end of this should be connected back to the wattmeter. And respective we need to connect the three phase load, resistive bank load. Okay, and similarly Here also you will observe that on the next part of it where the wattmeter was existing, on the same position the wattmeter should be copied, and we need to connect it as usual with the VV connection, which is connected back to your S2 and S1 of first and second transformer. And the voltmeter should be inserted across the supply side also and across the load side, which you have to observe it. Here which your here what is the observation you have to prefer is, since in the star connection you will find that the voltage which you are going to get, it is around the 440. Okay, so obviously we are they will be having many tappings on the board, so therefore we are going to prefer the as usual we are going to here we need to prefer the 50% of the tapping. Okay, so we have to connect it to the around the 50% of the tapping as your the P1, and P2 as usual we need to connect it at the next terminal. So here we are going to prefer the 50% of the tapping. If you are preferring this 50% of a tapping, definitely we have to go with the 50% of a tapping on the secondary side, because since here we are going since here we are going to use in the setup 2:1 transformer, that is 430/230 volts to 400/230 volts. So this indicates it is a 2:1 transformer. So here we are going to since in the star connection 440 will be the the 415 will be the that is nothing but the phase that is nothing but the phase voltage. So here on the line voltage you will get it as between this terminal and the next terminal, this will be around the 230. Okay, so it is V line divided by root 3. So on the board what you have to prefer is the primary side 440 will be the at the P1 terminal, but you should not take that, you should take 50% of it tapping, so it is 230. So we are preferring 230 here on the all the three transformers. So on the other side, no, we want 230 means you have to keep it on the 230 side only. Okay, so that is you have to make it clear while doing the connections. Now here this is your start to delta. So let us see that what you are going to observe in this case. So here you can see that this is what the procedure we have to follow. Vary the auto transformer till the rated value of the connected transformer. So that is we have to vary the auto transformer. Then suppose that is available here, which you can see that vary here what you have to do is you have to make the connections as shown in this figure. Okay, make the connections as shown in this figure. Keep the load, okay, keep the load switched off. All this load should be in the switch off position. Now you close the switch. Okay, then switch on the load in steps. Now you have to switch on the load in steps. For the each step we have to take down the readings of all the meters and continue that loading until the transformer supply the rated power of the respective configuration. Okay, that is how we have to just vary this load and note down the readings. That is what the tabulate the column, that is for the primary voltage, primary current, secondary voltage, secondary current. As well, what will be the input power that you have to take down from the W1 and W2, and also we have to calculate the constants of the wattmeters as we have seen in the previous sessions, and output power also we have to take it down, that is W3 and W4. From this we have to calculate the efficiency and the regulation. Okay, so now let us see for the next configuration. In the next configuration what you are going to do is, that is a delta to delta. That means the primary will be the delta and secondary will be the delta. Okay, so what is the difference here is, we have to connect earlier in the previous diagram we had the star connection, no? So in this case what we have to do, connect it in the delta fashion. connect it in the delta fashion. Okay, wherein we have to close the loop. So P2 is connected to P1, P2 is connected to P1, P2 is connected back to P1. That is what we are forming a closed loop. And on the other side, it will be written as it is. Don't vary this. But here, what you have to think about is in the delta to delta connection, you'll be having on the primary side, definitely you'll be having almost 415 volts. Correct. The same line voltage is also appearing onto the primary side of this. So that is why you need not, you have to prefer the primary side what 400 watt volts was there, that terminal only you have to consider it as your P1 terminal. Okay, you need not to connect it to the 50%, you have to connect it back to the 440 volts which is there on the primary side. That is what you have to take care. On the all of the three transformers, we need to select it as a 440 volts itself. Okay, on the secondary side, it will remain as it is. You have selected 230, right? So 230 only you have to keep it. Then again, the procedure wise, it will be similar. You have to make sure that load is in the off condition, switch on the supply, then apply the load. Okay, and take down the readings at each steps. We have to vary the load and we have to take down the readings. This is what we have to conduct the delta to delta fashion. Okay, so in this case, you can see that in the delta to delta configuration, what is the advantages? In the delta to delta connection, primary and secondary of all the transformers in a bank of a 3 single phase transformer will be connected in delta fashion. So this arrangement is mainly used in a system where it is going to carry the large currents on low voltages. Okay, that is what where you would like to carry the large current. At that part of the site we can make use of, I mean, this is mainly employed in the substation end of the transmission lines. Okay, where the main use with this connection is to step down the voltage. Right, from primary also you are getting some voltage, to the secondary side by the time it will get stepped down, but you will have the large current. Right, so that is what you can see in the delta to delta connection. Next, coming to the next fashion, that is a open delta. Open delta means in the open delta, see in the in the open delta you will find that in the open delta we will get that suppose in case if any one of the transformers in the bank of a three phase in a bank of a three transformers, if suppose one of them had got damaged, okay, so we have to service that. So the other two transformers, definitely it will work. So you not do worry about it. If one of the transformer is under the service, then you can make use of the other two transformers, but it will work with the reduced capacity. So that is what the open delta. Okay, so you can see here in this case, this is what the connection we have to do. The part of the connection here, the one of part of a transformers we have to take out the connection. Only T1 and T2 will be existing, and on both the sides you can see that it is appearing just like your 2 wattmeter method circuit, and almost on whatever we have done in the primary side, the same thing we need to follow it on to the secondary side. It is almost a 2 wattmeter method connection what we had studied a long back. Okay, and here also the same procedure need to be carried out, and we can see that even though with the two transformers we are able to carry some capacity, so with we are able to draw the power. Okay, that is what you can see in the open delta. Okay, so this procedure has already been we had taken up. And the tabular column, we have already seen that what all the readings we have to taken up: v1, i1, v2, i2, w1, w2, and w3 and w4. As well, we have to calculate the regulation as well as the efficiency for the each of the readings. So for the efficiency, the formula is output power by input power, and the regulation is we have to take down E2 minus V2 divided by the E2 into 100. Okay, so that is E2 is nothing but it is your no load voltage. No load voltage minus the loaded voltage. So this efficiency you can easily observe. Output power means definitely W3 plus W4 divided by W1 plus W2. At each steps you have to find out. As per the regulation means that is nothing but it is your, what is the formula for the regulation? That is no load voltage minus full load divided by no load. So where do you get that? The first reading whatever you are going to get, that is your the no load voltages. Okay, and the second reading will be from second reading onwards it is all loaded voltage. So you need to take a difference between the first reading with your the next followed by the next successive readings divided by the no load voltage. So that is your at the beginning of the first column, first reading what you have got. So like that you need to find out the regulation for all the steps with the different loads. So this is how you can complete all these three configurations and bring out the result. That is, a polarity test is being conducted on each of the three single phase transformer, and also this three single phase transformer has been connected in a different fashion, that is star to delta, delta to delta, and open delta. Okay, and also what we have done is since we are using three transformers, right, definitely we should know the performance of the each transformers. So efficiency and regulation has to be calculated under the balanced resistive load. So in the next session you can observe that how you are going to perform the connections, conduction as well as the calculations part. Okay, thank you for watching this video.